All right, guys, today we're going to start talking about motion. There's going to be lots of things that come with motion, but today we're going to start with distance and displacement. So if you could open up these notes, they're on Canvas. They say notes, motion with distance and displacement. You want to open these up and so you can follow along while I am going through them in the video here, because there'll be some things to write down and highlight as we go through them. So, motion. We're going to start with words and equations and calculations, and then eventually we will get to diagrams and graphs and things like that. But we're going to start with calculations. So while you're opening up your notes, I want you to, just in small groups with those that are sitting around you, kind of come up with a definition of motion. And then also think about an example that would support your definition. So go ahead and do this. Get in groups of just the people that you're sitting next to. Talk about what motion means. What is motion? Give an example. Just a couple minutes. Okay, so hopefully you guys were able to come up with an example of motion and what a basic definition of motion is, and hopefully it was something like this. An object's change in position over time is just a very basic definition of motion. So motion is describing how an object will change from one position to another position, from one point to another point over time. And we have to have a frame of reference when we're talking about motion. And a frame of reference is just a set of coordinates that can be used to determine positions and velocities of objects. That sounds like a very fancy, kind of wordy definition for frame of reference, but let's think of an example here. So, an example for frame of reference. So, you're sitting in the classroom. You're sitting down in your chair in the classroom, and we can describe your motion right now. Are you moving? Probably not. Okay, so you have no motion. You're not changing position. Let's think of a bigger frame of reference. Let's think about your frame of reference is the Earth. Okay, what is the Earth doing? It's going around in circles. It's revolving on an axis. Okay, so if you think about that, are you moving? Yes, you are moving. You're going around in a circle on the Earth. So the frame of reference is going to be really important when we're talking about motion. Okay, these are two videos that help describe distance and displacement, which we're going to really dive into next. I've posted both of these on Canvas underneath the notes where it says distance versus displacement videos. You don't have to watch both of them, but I would highly recommend watching one of them. At least. They're very good. They give visual descriptions of distance and displacement, what they are, what they mean, and examples. So both very good videos. Watch at least one of them after these notes. Okay, distance. So starting out with distance, you're probably very familiar with distance. Distance is what we think about it. It's very simple. It's just the total movement of an object. How much ground an object has covered. Okay, distance is a scalar quantity, and what that means is it doesn't include direction. It just includes magnitude or a number. It just has magnitude, no direction. We just say for distance covered, for example, we would just say I traveled 20 kilometers today in my car. Okay, I wouldn't say where I was. I wouldn't say Anything like that, I wouldn't include the direction. I would just say I traveled 20 kilometers. That would be a distance. Or 20 miles. Okay, I could say that I went however many miles today in my car. That is distance. A scalar quantity does not include direction. So very easy to calculate distance. You simply just add up all the distance you traveled or covered. If we look at this picture down here, let's say that we had an object or a person even. Let's say we had a person travel from point A, then they went to point B, and then they went to point C. So they started at point A and they ended up at point C. So let's say that this was 3 kilometers and this one can be 5 kilometers. So we would just add them up, 3 plus 5, that would give you 8 kilometers traveled. Okay? Units, meters could also be kilometers, centimeters, inches, miles. Those are all units for distance. Okay? Most of the time we will be using meters or kilometers. Okay? Let's see. So next we have displacement. And displacement is a little bit different. Displacement is the change in position of an object. So position is going to be very important. It's a vector quantity. And a vector means that it has magnitude, just like in the last one. It has the number, but it's also going to include a direction. Okay? So it's going to have a direction and a magnitude. It's a vector quantity. Okay. For direction, you could say north, south, east, west. You could give those cardinal directions, or you could say plus or minus, positive or negative. Typically, for these, you could say either one. I think a lot of times for our class, we're going to be using the directions north, south, east, or west, or a combination of the two, northeast, or northwest, or southeast, or southwest. They're going to be calculated by subtracting the initial position from the final position. So the formula looks like this. Triangle X, or delta X, equals XF minus XI. So the triangle here means change, the change in position. Okay? And then the final, the F is for final, and then the I is for the initial. So you're going to do final minus initial. And again, meters or kilometers, miles, inches, centimeters, okay, but mostly meters and kilometers for the displacement. Okay, so again, one more time with that triangle, the delta X here, that just means change, or you're basically, it just means to subtract. Okay, you're going to be subtracting. So distance and displacement are not the same thing. They have different meanings, different definitions. Sometimes they might end up being the same answer, but a lot of times they will not be the same. They're only going to be the same if a person or an object is traveling in a straight line. That would be the only time that they're going to end up being the same. So let's look at this example. A person walks from point A to point B, then to point C. So the distance, we calculated that earlier on the slide before, where we added up. So we had 3 kilometers plus 5 kilometers. That would give us 8 kilometers for distance. The displacement, however, we would only look at our initial position and our final position. We don't care about all the stuff that happened in between. And so from our point A to point C, the most direct route is 4 kilometers, and our direction would be, C is northeast of A. So it'd be 4 kilometers northeast. That would be the displacement. So see how 4 kilometers and 8 kilometers, they're not the same. Okay, so there you can just see the difference between distance and displacement. Okay, distance, we want to know the whole route. What did we cover? All the ground that we covered, the whole distance traveled. For displacement, we only care about the initial position and the final position. What is the straight line between those? So we have some practice problems here. Clarice drives her scooter 6 kilometers north. She stops for lunch and then drives 4 kilometers east. Finally, she drives 6 kilometers south to her friend's place. What distance did she cover? What was her displacement? Draw her route. Okay, so let's draw the route. That's going to be easy, the best thing to do, but it's going to help us calculate everything that we need to calculate here. So we're going to draw her route. Okay, so I've given myself a little bit more space here. So she drives her scooter 6 kilometers north. So let's say this is her starting point. Sorry, right here. Okay, let's call this point A. So she goes 6 kilometers north. We'll call this point B. This was 6 km. Stops for lunch 4 kilometers east. So east is going to be to the right. Okay, if you have your directions, here's north, south, east, and west. Okay, so those are the directions. 4 kilometers east. Okay, so that we'll call that C. Finally, she goes 6 kilometers south to her friend's place. So we'll call this point D, and this is 6 kilometers again. So what distance did she cover? So the distance, we just want to add up each of those routes. So it's going to be 6 plus 4 plus 6 is going to be 16 kilometers. That's the distance. 16 kilometers is the distance. So I just did 6 plus 4 plus 6. For displacement, okay, I'm going to change color here. For displacement, I only care about A and D. Okay, A and D. So, this distance here. And if I look, I know she went 6 north and 6 south. So, this line AD, we've got a little bit of geometry here. This line AD is the same as this BC line. Okay, I've basically made a rectangle. Okay, so her displacement would be 4 kilometers east. Okay, if she started at A and she ends at D, D is 4 kilometers east, okay, east of point A. So this is her displacement. All right, so let's try another practice problem. Using the image below, what is the person's distance traveled from point A to point B? Okay, well, to look at the line, look at the direction of the arrows. So they went from point A up to point B. So the distance is just 3 kilometers. Okay, remember with distance, there's no direction. It's just magnitude, just 3 kilometers. Oh, sorry, meters. 3 meters. My bad. I was still going off of kilometers. 3 meters for the distance traveled. Okay? Next problem. Number 3. Using the image below, what is the person's displacement from A to B? Displacement, again, with displacement, it is a vector quantity, so we need a direction. So we're still going from point A to point B. So it's still 3 meters. The magnitude is going to be the same, but now I have to specify a direction because it's displacement, and we traveled in the direction north, so north. 3 meters north. And yes, you would have to include that whole thing for the answer for displacement. Notice how the numbers are the same. So if you go back to the last problem, you'll notice it was 3 meters. This problem is 3 meters north. So the number part, the magnitude is the same, 3 and 3. And that's okay because we said if we're traveling in a straight line, the magnitude for distance and displacement will be the same. And it is 3 meters. But don't forget that for displacement, you have to include the direction. So for this instance, it's north. You have to include direction for displacement because it's a vector, not a scalar quantity. Scalar means it just has the number, only the magnitude. Vector, it has magnitude and direction. Using the image below, what is the person's distance, back to distance, traveled from point A to point D? So we're going to go A. We're going to follow the arrows all the way around, all the way to point D. So for distance, what we want to do is we want to add up all of those distances traveled, A to B, B to C, C to D. So we're going to go 3 plus 5 plus 3. Okay, so that's going to be 3 plus 5 is 8, plus 3 is 11. Okay, so 11 meters was our distance traveled. And again, I just did that by adding up all those distances traveled, all the ground covered. Okay, number 5. Using the image below, what is the person's displacement from the same amount of ground covered, from point A to point D? Okay, so we went up here, we went down, up, over, and then we went down. Okay, but remember with displacement, I only care about my initial and my final. Okay, so how far apart are those? They're 5 meters apart. So my displacement is 5 meters. Don't forget direction because it's a vector. Okay, what direction is it from A to D? It would be east. You have to include all of that in your answer for displacement. Okay. One more problem here, and it's kind of a twofer. So using the image below, what is the person's distance traveled and displacement from point A all the way back around to point A? Okay, so we're going to start here. We're going to go up, over, down, and back around to point A. So distance is, we're just going to add them all up. Okay, so 3 plus 5 plus 3 plus 5 is going to be 16 meters. That's my distance. That's how much I walked, or if I ran 16 meters. Not that far. Meter's just a little bit bigger than a yardstick, so not that far. But what's my displacement? Okay, so I started at point A and I ended at point A. So did my position change? Because remember, displacement is defined as a change in position. And if I started at point A and I ended at point A, I did not have a change in position. So my displacement is going to be 0 meters. 0 meters. Even though I did all this work, I went from A to B to C to D and back to A. I did all this work, but my displacement has not changed. I ended up back at the place where I started. So 0 displacement. Okay, hope this helped with your understanding of distance and displacement. Don't forget to go back and watch one of those videos before you start the assignment. Task 1, Intro to Distance and Displacement. Okay, when you finish that assignment, you can go ahead and turn that in. Don't forget to submit, and I'll be back tomorrow if you have questions, comments, or concerns. All right, have a good one.